Welcome back. This is Mr. Hassan's Maths channel, and this is a question from one of the IGCSE Cambridge paper 4 exams. This is from May-June 2017. This is the variant 1, so paper 4-1 from May-June 2017. This is question number 4 about graphs of functions. It says the diagram shows a graph of y equals fx for x values between minus 2.5 and 2. Okay, so you've got this graph that looks a bit strange here. Okay, and the whole of this first page is simply just this diagram. And on the next page starts the questions about this diagram. So the next page says find f1. Okay, so what we're going to do is find f1. So I'm going to take some of these questions and put them on the previous page next to the graph so we can see what's going on. So first we're supposed to find f1. Now what's drawn here is the graph of y equals f of x, and as we can see, a nice way of understanding this, as we can see, the 1 has taken the place of the x. So if we draw the line x equals 1 and see where it hits the curve, we can find the value of f1. Okay, fy is f1. So it's basically substituting 1 inside the function. That's how you do it. If we had an expression, we would take the function and we put 1 in place of the x, and we'd see what the y value would be. Okay, now we don't have the equation of the function, you have a graph. So that's how you deal with it graphically. So you take x equals 1, so you draw the line x equals 1. X equals 1 is a vertical line that passes through 1 on the x-axis. So it looks something like this. The thinner you draw it, the better. So x equals 1 will be a line that goes like this. Okay, and you draw it so that it basically meets the curve. I'm drawing it like all the way up. It only meets at the one place, but just in case. This is the line x equals 1. So that's what we have to draw to solve this problem. We draw the line x equals 1, and where this line hits the curve, we see what the y value is there. And we can see it's this place right here. Okay, I'll use a dotted line here. It's right over here. It meets the curve about there. So you can say it's like minus 1.5 almost. It's almost exactly minus 1.5. I think if I put this a bit higher, it would be just about right. Minus 1.5 would be perfectly fine. Okay, so you can see that's minus 1, that's minus 2, that's a halfway between them. Each of these is 0.2, 0.2, 0.4, 0.6, 0.8, so it's minus 1.5. Minus 1.5. So the answer to the first question is f1 is equal to negative 1.5. Okay, so there's the answer to part A of the question, negative 1.5. Now we're going to solve the second part, solve f of x equals 3. So we've got to solve the equation f of x equals 3. So we know, as we can see, it's y equals f of x. So it's like, if y equals f of x, it's like the 3 has taken place of the y. This is like, you know, y equals f of x, 3 equals f of x. So here we got to do the opposite. We draw the line y equals 3. Okay, if we draw the line y equals 3, it's going to be a straight line that goes horizontally across through 3 on the y-axis. This is the line y equals 3. And we see where this line hits the curve. And it hits the curve exactly at this point here. It's almost an exact, you can see it's like an exact kind of place. So I'm just going to draw from where it hits it, which is about there. Let me just draw it a bit neater. Okay, so it hits it right from here. So almost exactly at this point here. So we can see that that point is exactly negative 0.5. Negative 0.5. Okay, so there we have negative 0.5. So we can say this is where x equals negative 0.5. That's the solution to this equation. F of x equals 3. We draw the line y equals 3, and we see where it hits the curve, and we write down the values. Now we should also check to see, of course, it doesn't hit it anywhere else. That's the only place it hits it. Same with this one, we check to see it only hits at that one place. So there's just one solution, x equals negative 0.5. So that's what goes in this position here, x equals negative 0.5. Now we're going to do part C. Okay, so part C says the equation f of x equals k has only one solution between these values of x, which you can see drawn. Write down the range of values of k for which this is possible. So f of x equals k. K obviously is a constant. It's just a constant number. And so f of x equals k would be like a line y equals a horizontal line. So we want to find the range of values of k for which there's only one solution if we were to draw a line horizontally across. So if I was to draw a line horizontally across, okay, right, there should be only one solution, okay, for this with f of x, meaning it will only intersect it at one point and one point alone. So if we take this line and we move it up and down the graph, we can see that in all these regions here, there's one solution. Okay, there's just one solution. Okay. You know, so when f of x, for example, when f of x equals 10 or 9 or 8, there's one solution, and you can see the graph would continue going up. So up to infinity up there, it's going to continue going up, right? So when f of x is all of these values, there's only one place where it hits the curve. Remember, this is the curve. This is the curve that's drawn. This is the line that we drew later on. Okay, so you can see all this in all these regions here, there's just one solution. Okay, now the problem occurs when you get more than one solution is when this line hits the part of the curve which is like this down here. Now, for example, here there's three solutions. Yeah, there's three solutions. There's going to be three solutions all the way down as this continues going down this way. This will continue going down that way. There will be three solutions. In all these regions here, there will be three solutions. Okay? So basically, what we have to do is we have to think about where does it stop? Where does the one solution start? We can see it starts from up here, above y equals minus 4. When y is equal to negative 4 itself, there's actually two solutions. There's, well, some people would say three. There's a repeated solution there, so that's like 1, 2, and 3. All right, so that's three solutions, but two separate distinct solutions. That's one distinct solution, that's another distinct solution. Okay, and above that, there is only one solution. Okay, because it hits the curve only once, it doesn't hit it again anywhere else. So as long as the value of k is greater than negative 4, there will be only one solution. So the value of k, the range of values of k for which this is possible, is k has to be greater than negative 4. And there's the answer to part C. So k is greater than negative 4 is the answer to this part of the question. And then it says part D, by drawing a suitable straight line, solve the equation f of x equals x minus 5. Okay, so we got to draw a line and solve the equation f of x equals minus 5. Okay, so what's drawn is the graph y equals f of x. What we have to solve is the equation f of x equals x minus 5. So basically, we have to draw whatever's on the other side of the equation. We don't know the actual equation of the function, but we know that we have to solve the equation using this graph, the equation f of x equals x minus 5. So this is what's drawn, and on this side, okay, so that's exactly what's up there. So we should draw the line y equals x minus 5, and the places where y equals x minus 5 intersects with this curve will be the solutions to the equation f of x equals x minus 5. So how do we draw the line y equals x minus 5? Well, the line y equals x minus 5, we know about this line a couple of things. We know the gradient is 1. We know the y-intercept is minus 5. Okay, so we know that it goes through minus 5 on the y-axis. That's one way of drawing it like that. And we know the gradient is 1. So that means the gradient as a fraction is 1 over 1. So the rise is 1 and the run is 1. So for every 1 it goes up, it goes 1 across. Every 1 unit. So you've got to be careful. You know, you don't go 1 square and 1 square. It's 1 unit and 1 unit. Okay, so you can see that here, that's the one here. Let me just get rid of this for a second. there's 1 over here. It's kind of hidden under there. So from -5, you go up 1 and across 1. So it's going to go through this point, and it's going to go through this point here. So it goes through those 2 points. You could also say when x is 0, y is -5. When y is 0, x is 5. But the problem with that, we don't have x equals 5 on our axis here, so you can't really draw that accurately. So the best thing to do is to find 2 points in that range. So for example, if you're not too clear about what I just did now, going up 1 and across 1, you could say when x equals 1, y is equal to -4. So that's the point 1 minus 4, which you just plotted. So there's different ways of drawing these straight lines, but whichever way suits you is fine. Okay, so here we have the line. I'll draw it a bit thicker. In fact, no, I'll keep it thin. It's better. We're going to join these 2 points together. So I have to join these 2 points together and continue the line. So you've got to be very careful to continue the line on both sides so it fills out the whole axis. Okay, so it fills out the whole axis. So there's the line y equals x minus 5. Okay, I'm trying to make it as accurate as I can so that our answers come out accurately. You should use a thin pencil when you're doing this in the exam. Make sure you use a thin pencil. So this is the line y equals x minus 5. So the places that we're interested in are the places of intersection between this line and the curve. So we're interested in this point over here, and this point over here, and this point over here. What I'll do, I'll just highlight them as well so it becomes clearer. These are the 3 points that we're interested in, where the line that we've just drawn hits this curve. So I need to find the x values of those points, and those will be the solutions to that equation. Okay, so I need to find the x values of those points. So I can take this over here and draw it up there. Just make sure that that's right. Okay, so we can take it up here, sorry. Take it up to the axis so that we can see what number it's on. So that's over there. Okay, that's okay. I guess I could just move it slightly this way. It's not a big deal. Okay, so that will make it, that's -2. Now you can see here that's -1, that's -2. Each of these are 0.1. So -2.2. Whoops, I've left the highlighter on. Okay, so that's -2.2. That's one solution there. The other solution is in this point over here. So let's do the same thing. Okay, so that's going to be -1.2. That's -1.2. Yep, and then we got this third point over here where they intersect. And that is 1 point, that's 1 here, you see, 1.4. That's 1.4. So those are the 3 x values, okay, where they intersect. So solving this equation, the solutions will be x equals -2.2, x equals -1.2, and x equals 1.4. So I'll write the answers here. X equals -1.2, x equals -2.2, and x equals 1.4. Those are the 3 solutions to this equation, f of x equals x minus 5. Now, for part E, it says draw a tangent to the graph of y equals f of x at the point where x equals 1. Use your tangent to estimate the gradient of the graph y equals f of x when x equals 1. Okay, so we've got to draw the tangent to this graph. Okay, so we have to draw a tangent to the graph when x equals 1. So we go to the point x equals 1 and we draw a tangent. Okay, now let me just move this out of the way down here a bit. We draw a tangent, which is basically a straight line, which at the point where it's supposed to be the tangent, just touches or brushes past the curve without cutting through it. Okay, and we have to work out the... Okay, so the tangent is a line, as I said, which just brushes past the curve without cutting through it at that point where it's a tangent. And it has the same gradient of the curve. Okay, so I'm going to just draw a short line for now, but what you need to do is, you need to take your ruler the way you do it, and you need to put a line that touches the curve at x equals 1. Okay, and it has the same kind of slope of the curve at that point, but it doesn't pass through it, and there should be no space between them. Like right now, when I'm drawing this, when I've got this line, I can see this is a tangent to a point which is slightly bigger than 1. It should be at 1 itself. So you can take a bit of time to be accurate. It's not that easy to be 100% accurate in this type of question. So like I've got this tool, I can move these things around. What you've got to be doing is you've got to be doing this with a ruler. That's why using a clear ruler that you can see underneath is good for these kind of questions. And make sure it's a long 30 centimeter ruler, because what you'd want to do is draw this tangent as long as possible. I'm going to draw this so that it takes up the whole space of the axis. Okay, so I'm going to draw this all the way to the top. Now some people say, oh, it's going to cut through the curve up there, but it doesn't matter as long as it doesn't cut through the curve in this region where it's the tangent. Okay, it can't cut through the curve at this point here. Okay, it doesn't matter if the curve, you know, turns up and it cuts it there, that's no problem. At the point where it's a tangent, it doesn't cut through the curve. Like this line, this can't be a tangent, for example, because this is cutting right through the curve. It has to be a line which touches the curve, brushes past the curve without cutting through it through that point. So that's pretty, you know, as accurate as you can get, really. So now what you have to do is find 2 points on this tangent, which are easy to read, and then use those 2 points to find the gradient of the curve. So I'm looking for some points which are kind of on the easy side of reading. I can see there's one right here. There's one right here. That looks like it's pretty easy. That's like over here. That's, you can see this point here. I'm going to choose this point. I'm going to call this point A. And this point, as we can see, is that's 1.5 for the X. And for the Y, it's -4. That's a nice easy point for us to read from there. That's 1 point. And we look for another point that's easy to read, that's got kind of like exact values. You can see there's this point here. That point is pretty good. That's like 0 and 3.8. 0, 3.8. These are 0.2s. So I'll call this point B. So to find the gradient, we have to find you know, the gradient between these two lines. That will be the gradient of this tangent, which will therefore be the gradient of this curve at that point. The curve has the same gradient as its tangent. Okay, so if I now take these 2 points and I work out the gradient based on those two, you'll get the answer. So you should always show the points that you've chosen. Show where they are and write down those points. Don't just write down an answer for the gradient. Always show that you've drawn the tangent. Make the tangent as long as possible. That's why it's good to use a clear ruler and to use a ruler that's 30 centimeters long, so you can fill up the whole space with the tangent, and then choose 2 convenient points on that tangent and use those and show where you've chosen them, and then use those to find the gradient. So I'm going to use these points on the next page and we're going to find the gradient. Okay, so these were the 2 points. So we know that the gradient of a curve, the gradient of between 2 lines, 2 points on a straight line, are given by the change in y over the change in x. So it's going to be -4 minus 3.8 over 1.5 minus 0. So it's minus 7.8 over 1.5, which gives us our answer. Which is minus 5.2, minus 5.2. Okay, that's the value of the gradient. It's an estimate. It's not going to be exact. It's, you know, I think the range of values acceptable in the answer scheme is between -4 and -6. So this is almost bang in the middle. Means it's the closer it is to what's halfway between the acceptable range, the closer you are to the real value. Although in the exam you won't know what the mark scheme says, but that's, you know, as long as you've tried your best, it's fine. Okay, you've found you've drawn the gradient or the tangent as accurately as possible, and you found 2 points, read them properly, and use those 2 points to find the gradient properly. You should get the marks, no problem for that question. Okay, so there's the answer to this question number 3, I think it was. Number 4, from the May-June 2017 IGCSE Cambridge Paper 4 Variant 1. Other questions from this paper will be found in the playlist that should appear in this region over here. Other questions from graphs or functions can be found in the playlist that will appear in this area. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.